Now let's take a look at basic Linux skills or commands that you're going to use throughout your career as a Linux administrator / engineer. So let's unlock our screen. This will take us to the desktop, and once within the desktop environment we can open a new shell where we'll be doing the bulk of our work from. Now we can launch gedit from here, or we can also use the menu. Applications, accessories, gedit text editor, either or. If you launch it from the shell, then of course it takes over that shell unless you background it, and in either case it's executable. So we'll concatenate the contents that we develop here with our original notes when we started our installation momentarily. So let's label this section Basic Linux Skills, and basically this covers a number of key commands. Now Linux is a combination of, or an amalgamation of, dozens if not hundreds of useful commands, and these commands perform precise or specific duties precisely, which makes it so powerful because the utilities are dedicated to single to few functions, which means they excel at what they do instead of attempting to do all things for all scenarios. So for example, there's a command to tell you who you are on the system. There's another one to tell you which terminal you're connected to, where you're located within the directory tree, and commands to allow you to navigate the directory tree. So let's start off with some of these commands. 1. Explore common commands. One common command is the who am I command. In fact, let's number this because there's so many commands we're bound to easily exceed the number of commands, or the number of alphabets, number of letters in the alphabet. So the first command that we'll list, and we'll just remove this task altogether and just call it the name of the command, is a TTY command. Now we'll place commands between single quotes to indicate that that is how the command is to be executed verbatim. So whenever we specify items between single quotes, it means verbatim, whether it's a directory path or a command. So TTY, why is TTY important? This command reveals connected terminal. Now in a GUI environment, the connected terminal is likely to fluctuate more freely because the possibilities are greater. For example, here is a shell. This is the first TTY that's open. And if you look on the screen towards the bottom on the panel, there are no other TTYs open. So this is indeed the first TTY. The TTY command will tell us the number and name of this TTY. TTYs are labeled either as their pseudotypes or as their actual types on the console. So TTY tells us in this case that we're connected to dev pseudoterminal 0. When you use the GUI environment or connect via SSH, you're taking advantage of pseudoterminals. So reveals connected terminal. So in this case, the following was returned, which means pseudoterminal number 1, which is indexed at 0. So that's the first pseudoterminal. Now let's just note that terminals are either real, meaning console, at the console of the machine, or fake, meaning pseudo, auto-generated and accessible. And let's just also note that SSH and GUI terminals are pseudo. Let's just correct our spelling on this one. Whereas when you're connected to the physical console, it's a real terminal. So note, physical console terminals are real, and they follow the nomenclature TTY followed by a number 1 through n. And as we've mentioned in the init section, those numbers run from 1 through 6. And just to quickly recap that, let's see if we're able to take a look at the init directory And there we see starttys.conf is readable by all users. So if we cat its contents of etc init start ttys, it reveals that ttys are loaded from 1 through 6 for real consoles. So if you're connected at the console, 6 consoles are available. You can use Control-Alt F2 through 7 to get through to those consoles, with F1 being the GUI environment in this version of Red Hat Enterprise Linux. So back to our terminals. Every time you launch a terminal, a new shell, that shell occupies a TTY, whether sudo or real. So in this case, sudo terminal 0 is the first sudo terminal. And as you launch additional terminals in the GUI environment, additional sudo terminals are allocated. So to launch a new terminal, we can use Control-Shift-T, for example, as a shortcut to make a new window or file open tab, as you're able to do within the browser, which is Control-Shift-T as a shortcut. So there's a new terminal. TTY will tell us that this is sudo terminal number 1. And Control-Shift-T, sudo number 2, number 3. So the 4 shells correspond to sudo terminals 0 through 3. And as we close them, those sudo terminals become available for reallocation to other users. So if there are other users connected via the graphical environment, then they'll be able to take advantage of unallocated sudo terminals. So currently we've got 0 and 1 open. Those are sudo terminals. TTY tells us the terminal that we're connected to. Why is this important? Well, for a number of reasons, including but not limited to be able to determine where processes were executed from or are running from, TTY will tell you. Or when you query the process tree, for example, using PS, it will often show you processes that are tied to sudo terminals or real terminals. For example, just ad hoc, here is a process, min-getty, that's tied to TTY1. When init via upstart starts the system, it sets up a number of min-getty instances on various real terminals. These are the consoles that we interact with from the console of the system, whether via virtualization like VMware or physically at the console. So this tells us that min-getty is running on TTY1. And it's often important to know where processes are running to be able to connect to them or terminate them or interact with them or check up on them or otherwise. Here are other min-gettys that are running on real terminals or TTYs 2 through 6. Now, teletype terminals or TTY terminals derive from teletype terminals, which were configured to allow dumb terminals to connect to back-end devices like mainframe devices. So you had these dumb terminals connected over networks to the mainframe, and they were assigned as teletype terminals, dumb terminals, to allow the instruction sets on the server or the mainframe to execute, returning the output to the dumb terminal's screen. So input could be taken from the dumb terminal and output could be returned to the dumb terminal screen, with all storage and CPU processing and RAM utilization occurring on the back end on the mainframe. So this is where it derives from, out of the mainframe heritage. So TTYs 2 through 6, 1, and a number of other processes. Now notice that in the process listing dump, we see a bunch of question marks for a number of processes for TTY column. And that is because those processes are not assigned to a TTY. They were started by init and subsequent processes and do not require a teletype terminal or pseudo terminal. Not all processes require terminals. So for example, you could start a process on a terminal, let's say LFTP, close the session either purposefully or inadvertently, and the process continues to run in the background. Or you could start a process in the background that is unassociated with a terminal. But oftentimes programs are associated with a terminal because they're started directly by users, whether via SSH, Telnet, or from the physical console. So here we see PTS1, PTS0 indicating that the bash process, which is the shell, is operating on those pseudo terminals. That includes our current terminal as well as this terminal. So bash, the shell, is running on both of those terminals. And that's what's happening on sudo terminals 0 and 1. And if we were to launch a new sudo terminal and rerun the ps command from the second terminal, or sudo terminal number 1, we will then see sudo terminal, the new one, on the list, and it appears to be sudo terminal number 4. Let's just confirm it, and indeed it's assigned it as 4 where bash is operating. So bash is operating on a number of sudo terminals currently. Sudo terminals 0, 1, 4, and this is the grep statement that we executed. So in that case, we see the usefulness of TTY. It tells us where we can source connections. But there are a number of other commands, so let's not spend too much time on this one command. Another important command is whoami. Reveals currently logged in user. So from the shell, if we execute whoami and it is accessible to all users, it tells you who you're currently logged in as. Now, you usually can tell with the bash shell with whom you're logged into the system as, because the prompt is configured to reflect the user with whom is connected to the system and the host name in this particular case. However, there is a distinct command which tells you with whom you're connected to the system as, and that's whoami. Another important command is w, and let's just include w and who in a dump together, and we'll run them together. Now, who will show you the various terminals that are open by the current user, and w will show you the same information and then some, which includes the login time, for example, CPU utilization, and the process, more importantly, that was executed. So w gives you information like who, but it shows the process that's running on that particular shell. Now notice that in the case of w and who, they both show only the currently logged in user's processes. Notice now with who-a, it reveals various information, which includes the currently logged in user Linux CBT and his sudo terminals, as well as the console TTYs that were launched by the init process or root, which run as the login process, and other processes. So the who command, if you run who with the A option, reveals all users and their processes. So it's an extract from PS. If you run w, as we've shown you, this command will dump for the currently logged in user. Now all of these commands support a help option, so if you run w with dash help, for example, you'll see some options that may be specified to alter the output. W is terse, it shows you the processes, the CPU utilization, whether or not the process is idle, and at which point the user logged into that particular terminal, whether sudo or real. So reveals currently logged in user and processes, etc. So these two commands are important because they can tell you quickly who's running what on the system. So if you execute w, you see it for the user currently logged in, and if you execute it as who with the A option, you see processes that are run by other users. Also notice who with -a shows the PID of the process that's running, which means if you psef grep, for example, the process ID 32 or 3326, this will reveal from the process listing table that particular PID. So it shows here, for example, that 3326 started these various processes, and it shows up in the process listing. So you've got who and w as two important w commands that can help you to get information about who's currently logged in and what they're running. Now another important command is pwd. This tells you where you are within the directory tree. So it prints working directory. This becomes important as you navigate throughout the Linux directory hierarchy. So pwd, this tells us the full path, the absolute path from the top of the tree, or the root, the bottom of the tree. So prints working directory of full path from the root of the file system. This is important because oftentimes we operate from the shell and we navigate from directory to directory. So it's important to know where you are at any particular time. Notice that the prompt that's configured, the default prompt, shows the current directory, desktop, as opposed to the full path. It would take more space within our constrained resolution to show the full path, especially as the paths get longer with additional subdirectories, for example. So the current directory is shown in the path. Now this is all configurable. You could show the whole path, but it isn't usually practical. So PWD tells you where you are relative to the root of the file system, and it's important to know. Now let's continue. Some simple commands that carry over from other operating systems such as DOS and other flavors of Unix and Linux, for example, include CD. So CD changes directory. Very simple command, and you'll find it in most operating systems if you open a shell. So we're currently in Home Linux CBT Desktop. Now supposing this is not an ideal directory to be in, supposing we wanted to move one level up, cd ... brings us a level up. And now when we type pwd, we see that we are in Home Linux CBT, one level up from desktop. ... in the Linux file system means one level up. So for example, cd ... moves one level up in the directory tree. Whereas a single dot means current directory, which means you wouldn't change into it, but you could use it, for example, to list the contents of the current directory. So if you cd ... then you actually don't move within the tree, but dot is used to mean the current directory. So for example, ls ... enumerates the contents of the current directory. So CD is important as it allows us to move around the tree. You can also specify the absolute symbol, so cd / and then a path to move absolutely throughout the tree. So moves using absolute path, which means from the root of the file system. So cd / puts us at the root of the file system. PWD confirms that. ls shows us the contents of the root of the file system, and cd / home / Linux CBT returns us to our home directory, which brings up a couple of other points. CD accepts some shortcuts, including but not limited to cd > changes to currently logged in user's home directory, and will indicate home as the variable that's represented in the environment, which is uppercase home. So let's navigate back to the top of the directory, for example, or the root. Now we're at the root. PWD confirms it. Instead of cding / home / Linux CBT, we simply cd #, and this will place us into our home directory. Now this is mapped to the home variable. So if you're logged in as a different user, it'll change you into that user's directory. Now that variable can be referenced by echoing the home variable. Echo is yet another important command because it allows us to print to standard out or to somewhere else information. So the home variable is currently set to Home Linux CBT, such that when you execute cd #, you're changed into the user's home directory. So it changes into the user's home directory. Another thing we should note is that when you use a command such as cd with tab completion, it shortens the time required to navigate, so shortens navigation time. That's important because, again, let's navigate to the root. Now we're at the root. Now instead of changing explicitly to / home / Linux CBT, we could simply type the unique characters in the directory, such as HO for home, LI for Linux CBT, and off we go, using tab to finish the remainder of the characters associated with that directory. So tab completion is a bash feature. It's available in other shells like Korn, for example, but it's a bash feature that proves to be quite useful. So let's just note, use tab completion with shell commands. Let's just note bash shell commands to shorten navigation time. It allows us to move around rather quickly. Rather sophisticated feature. So that's tab completion, and there's still a number of other commands that are of interest to us. For example, we've been using ls. If you're unfamiliar with Unix or Linux, ls lists directories. So lists directories files. Files and directories are one and the same, with the exception of characteristics flagging one different from the other. In other words, everything's a file within Linux, but there are special types of files like directories, character devices, name pipes, and so on. So ls will list the contents of the directory. If you pass it no options, it lists the current directory. And it does so in short form. And it also does not by default show hidden items, unless you've configured an alias, for example. So ls lists current directory in short form. ls supports a number of options that are useful. For example, ls-l lists, and will include double quotes to include or to reference current directory in long form. Long form is most useful because it reveals the attributes that are important of the files that are of interest. So LSL. So here we see the same directory entries listed in short form, but with more meaningful information, including permissions, which we'll go into later, number of links associated with the object, the owner of the object, the group owner, the size of the object on the file system, the date and time associated or timestamp associated with the object, and last but not least, the name of the object, which in this case happens to be the desktop folder, documents folder, downloads, music, so on and so forth. So ls with the long form reveals those attributes. Now ls will of course accept explicit directory or file entries. So for example, ls-l, the root of the file system, lists root in long form. So although we may be in a different directory, /home/Linux-CBT, we can interrogate other directories. So we are in /home Linux-CBT, but we may list the contents of anywhere else for which we have permissions to interrogate. So here we see in long form the contents of the root of the file system, which includes permissions, number of links, and the owner and group owner's size, timestamp, and the name of the object in the directory tree as it's known in that particular location. So as LSL, long form, and there are a number of other attributes. Supposing you wanted to see hidden items, for example, there's the A option. So we could use long form and A, and this will show hidden items. And hidden items within the Linux directory tree are prefixed with a leading dot or include a leading dot. So for example, .ssh means that this is a hidden directory named lowercase ssh. So we now may enumerate the contents of that directory. So long as you know the name of the directory, whether hidden or not, you may enumerate the contents of it without using the A option. The lowercase a option simply reveals the hidden items. So for example, AL, and the order in which you indicate the option is irrelevant. So lists current directories entries, including hidden items. And those hidden items may be files or directories. And then once you know the directories or files, you may interrogate them. For example, .ssh is a directory. Notice the colorization, that items in blue are directories, items that are black are files. So here is a file that is hidden, pulse-cookie, and here are some others. You may enumerate the contents, for example, the X-authority file. So let's LSL and use tab completion to help us, and there's the lone item. So you can specify individual items as well. You may also specify lists of items. So let's list a number of hidden items in particular. So LSL, X-authority, that's one item. followed by SSH, which is another item, and it happens to be a directory. So lists multiple items. And you can also mix and match hidden and non-hidden items, so you're not restricted to one or the other. So let's just take a look. So this lists the X authority item first, because we indicated it first, and the SSH directory second. And let's add a non-hidden item, such as documents. And there it shows the documents directory. So the SSH item came last, documents second, but nonetheless it listed all three. Now both documents and SSH contain no items, which is why the totals are returned. Notice that ls returns a total number of items that are returned by your query. So notice when we run ls-l, it returned a total of 32 items. However, we see what appears to be 8 items, and that's because the rest of the items are hidden. So let's ls-la, turning on the hidden option, and now it returns even more items, 144 items, and a number of items that are hidden. So there are a number of items that are here that causes it to return. These are the 32 that we see on the surface, but then throughout the tree it totals n number of items, 144 items. So ls is used to enumerate the contents of directories and files. And a number of options are supported. All sorts of options, including sortability. So you can sort, let's go ahead and lsltr, which I like to use a lot. So sorts with most recent at the bottom. And this is useful in the event that you have a lot of items in your directory and you'd like to see the most recent entry at the bottom. So in this case, all of these entries were made at the same time as a consequence of creating the user, which is why it's listed as it is. That's lsltr, the root file system. Now, if you follow the root file system, you'll see that the older items from 2009 are at the top of the list. The newer items from 2011 are at the bottom of the list, with the most recent item created at 1157, the temp directory, at the bottom. Now, the temp directory was perhaps not created at 1157, but rather updated at 1157. Whenever directories are updated, then the timestamp is updated to reflect it and will cause your ls output to change as a consequence. Now, if you want to learn more about ls, run it with the help option and you'll see the myriad options that are supported. There are truly a number of options that may be useful to you. Just run it with the help option. Now there are more commands. Let's move on. For example, touch. Touch is important because it allows us to create files. So it creates 0-byte file or updates timestamp on file. And let's just note on pre-existing file. So it's a utility that will allow you to update the timestamp information on one or more files, or will allow you to create a 0-byte file. Many scripts include a reference to touch to create a file, a 0-byte file, for the sake of perhaps executing branches of scripts or checking conditions, or just for sanity, or perhaps creating a PID file, process ID file, when invoking a particular process. So in our directory, let's lsltr, which we'll use a lot, and there are no files that we've created to date. Let's touch test.txt. So now we have a new item. Let's rerun lsltr. By the way, the bash shell supports the ability to search through the command history using the up and down arrow keys. So I've been using up and down arrow to navigate through the history items for this particular shell. And if you type history, which is yet another command, it shows you all of the commands that we've run, with a configured number of commands to be saved to be 1,000, but that can be altered with the bash configuration file. So let's lsltr again, and now you'll see that test.txt with a stamp of 12 or noon has been created, and it's indeed 0 bytes. So it contains nothing. However, it's a file, and it's on our file system, and it can be interrogated at any particular point. So use touch to create those files. Now, what if we wanted to update the timestamp on the file? Well, the date command tells you the current timestamp, which is 12:01 and 22 seconds at that point. Let's touch test.txt again, and this will not change the contents of the file, but however, it updates the timestamp to 12:01 accordingly. So in the event that you need to, for a script purpose or other purpose, update a timestamp, use the touch command. Now again, nothing's in it, so for now, it isn't of interest. Supposing we wanted to update the documents entry, let's touch it. It exists, of course. And let's lsltr, and notice that documents is now sorted towards the bottom because it was updated at 12:01. Then let's touch test.txt again, and then rerun lsltr, and now test.txt is the most recently updated item in our directory tree. So touch is one to watch because you'll see it in scripts reference, and you'll use it from time to time in your own scripts or as you navigate about the Linux file system for various purposes. Let's create another entry here for the echo command. The echo command echoes information to a default of stdout, standard out. If you're unfamiliar with standard out, standard in, standard error, it simply means of capturing information into and out of the computer while capturing errors as well. So echo echoes whatever you tell it to echo. So for example, echo between double quotes, this is a test. This will dump to standard out, this is a test. And if we send it to a file, it'll echo to a file. Echo, this is a test. Or echo, hello world. So this echoes to the screen. Now echo is quite useful in scripts or for just general navigation. It's good to know that there's a command that will dump information to the screen for you. And that's echo. Now let's move on. Of course, we'll be using these throughout our studies, so we'll reference them in more detail as we move forward. Another important command is cat, which is short for concatenation or catenation. So it concatenates or brings together content or amalgamates content. It also will dump the contents of a particular file or files, but its chief purpose is to allow you to concatenate or amalgamate content in a logical fashion. So let's take a look at something that we can do here. Let's cat test.txt. Now test.txt is empty, but nonetheless, it will open the contents of the file. So cat test.txt, and it's going to return nothing. But nonetheless, it did open the file and attempted to enumerate the contents of the file. Now, whenever you run a command within the bash shell, it's a good idea to echo the most recent exit status by referencing the question mark variable. Question mark variable contains the exit status of the most recently run command. Let's just note that as an interjection. So note var contains question mark var the exit status of the most recently executed command. It's very helpful to echo this variable as it's used when checking for failure or success in scripts. When you see an exit status of 0 in Unix or Linux, it means that the process, from the process's perspective, executed correctly. It doesn't always mean that the script or process did what you intended it to do, but from its perspective, the way it's programmed, it was successful. So the cat of test.txt was successful. Now let's use echo to put some information into that file. We'll use echo, and let's put hello world in it. And this time we're going to use append redirection to write to test.txt. Let's echo the exit status, and it's 0. So that means the echo of hello world, which was redirected, which we've yet to discuss, to test.txt was successful. Now let's recat the contents of test.txt. We'll just go through our command history. Test.txt now contains hello world. Now if we keep using append redirection, let's do it 5 times, you'll then see when we recat the number of items in the file. So it just keeps appending. Whereas if we use output redirection, which means one greater than symbol, it clobbers the file and writes it anew. So this contains one entry. So cat echo in conjunction to query and generate and query content. So cat does that for you, but cat more importantly concatenates multiple files. So for example, let's cat test.txt and test2.txt to test3.txt, which we've yet to create. Well, this will create it for us, but we haven't created test2.txt. So let's create a test2.txt. We'll echo hello world and we'll call it 2 to test2.txt. So now when we cat the contents of test.txt and test2.txt, they're distinct, hello world and hello world 2. So now using cat, if we cat both of them, test.txt and test2.txt, this will send the output to stand it out in the order presented on the command line. So first test.txt was read, then test2.txt was read. Now, if we send the output into test3.txt, a new file will be created, lsltr, and its contents will reflect the amalgamation or cumulative size of test.txt and test2.txt. So let's cat the contents of test3.txt, and there we see both lines. Test.txt is 12 bytes, test2.txt is 14 bytes, thus test3.txt is 26 bytes. So this is one example of using cat to take two files and send it to one. This could of course be expanded to much more intense situations. Think about log files that are gigabytes in length that need to be concatenated. You can simply reference the files one at a time on the command line and dump their contents into a single file, and that will work for you. Now, as mentioned, cat is useful for enumerating the contents of any largely textual file. So config files, for example, are prime targets or candidates for enumeration and interrogation using cat. Just cat followed by the name of a file will send the file's contents to stand it out so that you may use it. So thus far we've covered who am I, which tells you who you are, W and who, as well as PWD, CD, LS, touch, echo, cat. And let's just throw another one in there that comes to mind, and that's ID. This gives you a little bit more information about who you are on the system. So indeed, we are the user Linux CBT, but it also tells you your ID, your group ID, the groups, your primary group, your SE Linux context. So ID is much more useful in determining who you are. So returns UID, GID, groups, and SE Linux context if enabled, as it doesn't necessarily need to be enabled. ID is another command that you can use in conjunction with who am I to determine who you are. And as a user root, you can ID any user on the system. Now, let's save the changes that we've made thus far. We'll be concatenating this with the original documentation momentarily. So we'll call this Linux CBT EL6 edition notes 2.txt. And since we've reinstalled the system, we'll have to bring the notes over in order to concatenate the two. And by specifying notes.txt followed by notes2.txt in the appropriate order, then the content will be concatenated accordingly. Now there's still a number of other commands to explore, so let's move on in the next section by examining those additional useful Linux commands.